Okay, so let's change the writing mode. Ooh, what happened? It's like stuck. Okay, 1 second. What's wrong with it? Okay, my thing is like not responding. Okay, maybe if I do it again. There we go. Nice. Okay, so I think you should be able to see my writing screen now. Okay, so we're gonna go and talk more about sampling, but let's sort of review a little. I know it's been a little while. So we talked about how the point of random sampling was to reduce bias, and I gave you this example of when FDR was running against something Landon, how there was this big poll survey that was done and ended up being really inaccurate. Why was that? Because the people who were involved in the poll or survey skewed very conservative and they were much more likely to vote for Landon, even though FDR ended up winning by a landslide. So we talked about, how do you avoid bias? Well, you need to do random sampling, and we sort of talked about the stages of how this goes down. You start with a list of everybody in your population, right? So I gave you the example of the census, which has the master address file. And then you do the equivalent of like flipping a coin for everybody. You need it to be that everyone has the same chance of being included in the sample, right? So you can see my list there, like of the 6 people, right? And it gave an example, like imagine flipping a coin, like is this person in the sample, is this person not in the sample? And we had a special name for this. It was called a simple random sample. Okay, so a simple random sample is you just start with your list, you like flip a coin for everybody, and like some percentage ends up in your sample or not. Okay, and then we talked about how, however, that can still have bias. So I started talking to you about the stratified random sampling. So the way stratified random sampling works is that first you break your population into strata. So I drew this little picture here. You can see like a little square, rectangle with all the different colored dots in there. Our strata in this case was race. Right, so white people were the white dots, Asian people were the purple dots, black people were those like brownish looking dots. And so the idea is that to make sure that you always get some white people in your sample, some Asian people in your sample, and some black people in your sample, you first take that list of everybody, the master list, and you break it up by strata. So you have a list for whites, a list for Asians, a list for blacks. In other words, for each of your strata. And then what you do is you take a random sample from that. Okay? So what you'll end up with is like 10% of all the white people, 10% of all the Asian people, 10% of all the black people. This was important because I gave you an example where, let's say you had like a town of 100 people and there were very few people who were neither white nor black. If you took a 10% sample, they may not end up in that sample. So a stratified sample makes sure that all groups are included so that there's no bias. Okay, so hopefully this is like ringing a bell from last time. Are there questions that we want to ask about the old material before we move forward? So I'm just going to pause. It looks like people are like writing and thinking. So I'm just going to give you a moment. I want to point out that these strata, so like your strata of like all the white people, the Asian people, and the black people, the people in the strata have something they share in common. So everyone in the strata has some similar thing about them. So if your strata are race, does it make sense? We're saying all white people are similar in the sense that they're white. All Asian people are similar in that they're Asian. All black people are similar in the sense that they're black. There's something about them that we're using to group them together in a strata. Okay, that's an important point here. So you get these groups of people who you are assuming have some sort of similarity. So the assumption here is that the strata, that the subjects in the strata have some sort of similarity to each other. So that's why this sampling method is very useful, because you're saying like, look, I know that these three groups of people, I want to have information about all of them because there's some sort of similarities about them. I don't want to make sure that I systematically ignore one of the groups. Okay. So let me talk about another sampling method called cluster sampling. So there's strata sampling and there's cluster sampling. I called it cruster, that was bad. Okay, so there's this different thing called cluster sampling. It's gonna seem very similar to stratified sampling, but there are some differences. Okay, for stratified sampling, you make your strata, and the people in those strata have some sort of similarity to each other. Cluster sampling is very similar. You start with your population and you break it up into clusters. Now, the difference here is that while the strata, the people in each strata were similar in some way, like everyone in one of the strata was white, everyone in the strata was Asian, everyone in the strata was black, the clusters are not supposed to have something similar about them. So the subjects in the clusters are not supposed to be similar to each other in some way. So we call this a heterogeneous group. So clusters are heterogeneous, the people are not similar to each other. For stratified sampling, strata are homogeneous or homogeneous, which means they are similar in some way. So for stratified sampling, the groups have some sort of similarity. For cluster sampling, when you break them up into the groups, which we call clusters, there's nothing about those people that, like, you're supposed to say, like, oh, you can tell they're this group. It's just supposed to look like a random mix of people. Okay, so it ends up being really similar the way this works. For cluster sampling, you break your population into clusters, and then you take a simple random sample of some percentage of each cluster. So just like, it's very similar to stratified sampling. You break your thing into groups, and then you take a simple random sample of each of your groups. The difference is whether the groups are comprised of similar looking people, that's stratified sampling, or if the groups are comprised of people who have no similarities to each other, that's cluster sampling. Oh my gosh, I'm sorry. I wrote this wrong. Cross out number 2. This thing that I said here is wrong. I'm so sorry. I need to re-say what I said. I'm going to explain it with a picture. I realized that I did not say what I wanted to say at all. Okay, let's say here's your population. And let's use those colors. Let's say that blue means it's an Asian person. Green means that it's a white person. And red means it's a black person. Okay, so I'm gonna like put some dots around. Okay, so everyone see my Christmas tree lights, basically? Each of those is like a different sort of person. Okay, so if you look at this, do you see how like there's no obvious groupings? Like you can't tell like, oh, in a particular region there's a lot of Asian people or a lot of white people or a lot of... yeah. Thank you for pointing that out. There we go. I did not mean like to derogatorily say red people as a Native Americans. I don't know why I wrote that. But thank you for pointing that out. Yeah, I noticed that actually when I looked at it, I was like, the moment you said that, I was like looking at it and I was like, why did I write red? Okay, so what you would do is you would make your clusters like this. So like you could just like split up this region. You could go like this. Okay, so do you see how like I drew a little white line right there? I could call that cluster 1. Everybody who's in that cluster, everybody in that area is in cluster 1. So if you look at this, do you see how it's like you have a nice random mix of Asian people, white people, and black people? This is not a strata because in a strata you would hope to have like a majority of one type of group or something. You would want only Asian people, only white people, only black people. Because it's a nice mixture, this has to be a cluster. So you would just like break up the region by doing something like that. You could call this cluster 2. And then, I don't know, this one would be like cluster 3. And that one would be cluster 4. And you look at each of these and you're like, oh, this is nice. Like, I have a nice mixture of everybody in the different clusters that I've chosen so far. They're heterogeneous. They're not homogeneous. Okay, so now that I've broken up my population into clusters, what you're going to do now is randomly select a certain percentage of the clusters. So what that means is that you either get everyone in the cluster or no one. So what you would do is you'd flip a coin, and let's say it comes up heads, then cluster 1 would be included. And let's say you flip a coin and it comes up tails, cluster 2 would not be included. So you would throw out everybody from cluster 2. You would only look at the people in cluster 1. And then you would keep on doing this process. You'd flip a coin for cluster 3, let's say it comes up tails again, you would throw out everything from cluster 3. So does that make sense? Because 2 and 3, clusters 2 and 3 are not included, you don't get anyone from those. But because cluster 1 was included, you get everybody in that cluster. And then let's say you flip a coin and cluster 4 is in, you get everybody in cluster 4. This is different than stratified because in stratified sampling, you got a percentage of people from every cluster. Stratified sampling is different since you are assured some percentage from every strata. Okay, cluster sampling is all or nothing. You do not get anyone from cluster 2 or cluster 3. But if they were strata, you would have gotten some percentage from them. Okay, so I'm going to give you a moment to write that down. I'm just going to quickly go and get some tea. Okay, I'm back. Okay. So, any questions about the differences? You need to understand this, not because you're going to have to do it, but because if you ever have to use statistics in real life, it's important just to know how they got their sample. It's nice to be able to read, the results of something and realize, oh yeah, they had a stratified sample, so we're gonna definitely have someone from each strata, or they did cluster sampling. I know that some of the clusters weren't included, and it gives you a background about what you're dealing with. Okay, so does that make sense? You just need to understand conceptually what's going on. Are there any questions about the differences or similarities between these two methods? Mm-hmm. Yes. Yeah. And it's actually the same for each group. So if I scroll back up, just go back up to here. Yeah. So you take a simple random sample of each strata of some fixed percentage. So each strata would be 10%, or each strata you'd get 30%. So it'll be the same for each of them. How much information you need, basically. No. So for cluster sampling, you want to know what percentage of clusters you'll get. So in this case, I decided to randomly choose half of the clusters. So I had 4 clusters, I ended up with 2 of them, right? That's half. Mm-hmm. That would be given to you just to let you know in a question if you were reading about it. If you were gonna actually use this in the real world, you'd take more classes where they would explain to you well, what percentage of the clusters should you choose? What percentage of each strata should you choose? For anyone who's wondering about that. Okay, cool. Yay! So there's one more topic we're going to talk about before we go back to Wolfram. So we ready to move on to that? Can I move away from here? Are there any objections? Just want to make sure that everyone's been able to write everything down that they need before we move on. Okay, awesome. Okay, cool. So we're going to talk about variables and data. Okay, so let me set this paper up. There we go. Okay. So, how do you start analyzing your data? Okay, so what we're going to do first is we have our data, and the data is filled with variables and the values of those variables for each subject. So do you remember in Wolfram, when we load the data, you can see the different columns of the different variables, and then if you look at those columns, you can see what value each of those subjects had. Okay, so the method that we're going to use to start analyzing each of the data is we're going to look at one variable at a time at the beginning. So we're going to start by analyzing one variable at a time. So let me just like make up an example, like some let's say we have some data. So we're going to have data about the gender of people. We're going to have data about their income. We're going to have data about their age and their ethnicity. So let's say you have these 4 variables. Now, does it make sense that how old you are might affect how much income you make, right? People who are younger probably make less than people who are older. Likewise, your ethnicity might affect your income. People of certain ethnicities are less or more likely to make more money. What else might affect your income? Your gender. So do you sort of see here that we have like one variable that seems like it's probably affected by all of the other variables? We're not going to worry about the fact that all of those things affect income. We're just going to look at income by itself at first. Or we're only going to look at gender by itself at first. Okay, eventually we'll talk about the interactions between variables or their relationships, but that's later. Okay, so for now we're just going to look at one variable at a time. Interactions and relationships will come afterwards. Interactions / relationships between variables we will discuss later. Okay? And looking at those interactions and relationships between variables is like one of the whole points of statistics, but we're not ready to go there yet. We first have to talk about how do you look at a single thing by itself before you can talk about how two things interact. Okay, so does that sort of clear up like what we're going for here? We're going to look at the one thing. And like usually people don't like doing that because they'll say like, oh, why should I only look at gender? Like gender and income might be related. And it's like, yeah, we're going to do that later. Right now we're just looking at the one. Okay. So when you analyze one variable at a time, what we're going to do is we're going to look at the distribution of a variable. And looking at the distribution of a variable means to look at all of the values for all of the subjects at the same time, so to speak. So like let's say you're looking at income, you're going to look at all of the information about all of the incomes for all the different people in your data set. And you're going to try to figure out what all that information is telling you. When you do that, that's called looking at the distribution of the variable. You're somehow taking into account all of the income information you have, or all of the age information you have. Okay, so when we talk about the distribution of a variable, it's sort of this like big analysis where you're looking at all of your information you have about that variable. And there are two ways to look at the distribution of variables, and it has to do with what sort of variables you're dealing with. Does anyone remember the two major types of variables that we have? Do you remember? Excellent. Yeah, cool. So like, if you're dealing with a numerical variable, there are certain things you're going to have to do to look at its distribution, and that will be completely different than if you're looking at a categorical variable. Which is why we have these two different types. You're gonna deal with them in completely different ways. Okay, so that's why it's important to be able to understand the difference between them. So like to look at the distribution of a numerical variable is completely different than looking at the distribution of a categorical variable. sorry. I'm like looking through my book to see where I was. I'm like, okay, I'm like right here right now. Cool. Okay, what time do we go until today? 2:15. Okay, so we have 45 minutes left. Okay, so I think this is the perfect place for us to stop, take like a 5-minute break and transition into that. Next class, we're going to pick up with, so how do you actually look at these distributions? Today I just wanted to talk about that's what's coming next. All right, so I introduced that. I also talked about the last thing we need to talk about for random sampling. Okay, so does that make sense? Let's take a 5-minute break. Let's come back at 1:35, and then we'll continue with Wolfram things.